This is our agenda for today. We'll try to stick to it as much as we can. The plan is to finish within 60 minutes. We'll keep the last 5 minutes for questions and the 10 minutes before for a quick demo. So when we talk about modern development and integration, every company or an individual believes it's a lovely journey where we build lightweight services, mostly REST services, supporting JSON data format. Something very small, fast, lightweight, highly scalable, and cloud native. The real experience tells us something different, that there are many obstacles hindering this dream to become reality. One of the main challenges is how to deal with the legacy or monolithic applications and how to integrate them with the modern services, rather than just dropping those monolithic applications, which anyway will not be accepted by the business community. And to define a monolithic application in this context, we are talking about an application that was built with an old method at a single tier in most cases, designed as a single deployment unit with modular architecture and interdependent module deployment model. So adding to this legacy application challenge, we also, when we develop new services, we definitely develop them in an agile way. So to be in line with the agile development, we need to bring the agility to the integration domain as well. So where is the problem? The problem is that the integration was born as a monolithic workload. Since SUA concepts, those concepts were realized by products like enterprise service buses, where every enterprise service bus is a central component that requires all these services to come back to the ESB for sake of using its connectors, its mediation engine, or its transformation capabilities. So moving such big install base, which is called the ESB, between different environments, different infrastructures, we would also say between different clouds, either public or private clouds, or even a hybrid cloud, is a big challenge. Also, achieving high availability with this hybrid deployment model and scalability is a nightmare. Adding to it that most of the time for those services running on top of the ESB, they require different SLAs in terms of their availability, their scalability, their resource requirements. So it was never ever an easy job to deliver different SLAs for those services running on the same ESB. The new integration approaches are promoting something completely different. Rather than having the central deployment model, those approaches are promoting what is called distributed integration. Looking at two big names like Gartner and Forrester, both of them refer to this fact in many researches and articles, including the very famous article by Gartner, Enabling Agile Integration with a Distributed Integration Platform, with a very focused and clear message that traditional ESB architectures hinder the operational and architectural agility of integration tasks. Also, Forrester was focusing more on successful firms with an agile integration strategy, release and update of APIs and integration capability, either weekly or daily, or nearly 3 times more frequently than less successful firms. So agile integration is our main focus today. And for us, bringing agility to the integration domain can easily mean adopting principles like microservices, packaging those microservices as containers, running those containers on top of a platform that allows us to run those containers securely at scale, and allowing this platform to run on top of any cloud or elastic infrastructure. The second concept in our today's session after agile integration is the pervasive integration. So pervasive integration is the art of possible in the integration domain. It's another interesting approach focusing on 4 different pillars or capabilities. The first capability is the pattern-based integration. So simply the implementation or the full implementation of the enterprise integration patterns. The second capability is the hybrid deployment model. Simply being able to deploy the integration services on-premise and on the cloud, either public, private, or hybrid clouds. The third one is the co-location of the integration and the application services. So it is no longer taking your application away while the integration capabilities has to go back to a central place where the integration can be done away from the application services. No, both they have to be co-located. The last capability is the multiple personas, right, with proper user experience. We will focus more on citizen developer. This is one of the topics under multiple personas, as one of the personas defined by pervasive integration. So a citizen developer is the opposite of core developer. So this could be even a completely non-technical resource. For example, a marketing specialist. He needs to extract data from social media and later enrich data, right, using, let's say, the enterprise CRM system, and finally publish this data for some partners or marketing agencies. Yes, this is one of the personas targeted by pervasive integration. The citizen developer definitely will deal with less sophisticated tools than the ones core developers deal with. So, simply, no IDEs, low or no code, no complex build processes, no complex packaging processes, and hassle-free deployment process. The technology stack that is adopting and realizing agile and pervasive integration is the unbeatable technology every enterprise IT is willing to have today. And in the following slides, we will explore together the Red Hat Agile Integration Platform and understand more about what comes with the integration platform in terms of features of each and every product shipped with the platform. In the next section, and before we navigate through the Agile integration stack from Red Hat, we will quickly discuss the proposed reference architecture for the distributed Agile integration. As we can see, a typical open layer architecture with cross-cutting services. Each layer is a set of microservices. So the open layer architecture, because some requests are allowed to bypass the middle layer and go directly to access the layer below it. So looking at the first layer, the one at the bottom, right, where we build the base microservices. Sometimes we also call it anti-corruption services, right, or anti-corruption layer, where all the technical services are deployed. So the technical or anti-corruption services, the main responsibility for those services is to translate between the back-end systems domain model and the new domain model managed and exposed by the new services. Think of it as a set of connectors, maybe basic data transformation capability. Going one step up, looking at the second layer, this is where we have the surface composition and surface aggregation. There are very well-known patterns commonly used to build this layer, like, for example, the aggregator pattern, the proxy pattern, the chaining pattern, and even the very famous asynchronous communication pattern. So the services deployed in this layer are able to mediate requests through different technical services. For example, acting as filters, splitters, aggregators, maybe routers with some content-based routing, dynamic routing, enrichers, and so on, right? So in addition to also supporting data transformation. Now the third layer, this is the micro gateways layer,
where you streamline and control the traffic to your internal microservice deployment. At this layer, you have the gateways, where we usually apply security and enforce policies. And at the same time, we avoid any heavy data manipulation or data transformation, because we need to keep those gateways lightweight and very fast in terms of handling the requests and routing them to the proper service composition layer. Coming to Red Hat technology stack, looking at Red Hat technology stack, we can see that the technology stack provides full implementation for this reference architecture. So the Red Hat Agile integration is a comprehensive set of Agile integration and messaging products. Those products, they provide wide range of connectors, either technical connectors or even business connectors or social connectors. We'll see more in the next slides about the connectors shipped with the platform. Also, this platform provides a service composition, orchestration engine, real-time messaging and message streaming, API management, and security infrastructure. So all those products are combined together, well integrated, containerized, DevOps enabled, running on top of Red Hat OpenShift container platform, and also designed bottom up to be a cloud native workload. So this technology stack includes the Red Hat application runtimes. This includes wide range of runtimes and frameworks to speed up the service development, including, for example, OpenJDK, Spring Boot, Vertex, Sontail, JBoss EEB, Wildfly Swarm, OpenLiberty, Red Hat Data Grid, and Node.js runtime. The second product in the stack is Red Hat Fuse. This is the main integration hub that provides the connectors and also the mediation engine. Then Red Hat API management. This is a complete API management platform, including the policy management and policy enforcement. And last but not least is Red Hat MQ, providing the message broker as well as the data streaming through Kafka distribution. So in the next 20 minutes, we will give you a quick overview about this technology stack. Definitely, we'll come across all the products, but with a very high-level overview because of the time limitation. After this event, we will share with you more details, including slides and demos. Okay, the first product, Red Hat Fuse. Red Hat Fuse is a distributed cloud-native integration solution. Like any other integration hubs, including the traditional ESPs. It comes with connectors, mediation engine, and data transformation, the core capabilities or the main pillars for any integration platform. Fuse is a combination of more than 250 components, connectors, or sometimes we call them adapters. It also provides full implementation of the enterprise integration patterns and support for more than 30 data formats, including the most commonly used ones, XML, JSON, and so on, right? Also, it provides 15 different expression languages to write the data transformation logic. The main engine running within Fuse is Apache Camel. As we all know, Apache Camel is a Swiss knife of integration, one of the most active projects in Apache community. Camel provides its own DSL, domain-specific language, right? This is the integration-oriented script engine or a language. This can be written either in Java or in XML. Next to Camel is CXF. This is the Apache CXF project, one of the most commonly used web service frameworks, with JAX WS for SOAP services or JAX RS for RESTful services. Fuse through CXF can allow non-developers to simply implement such services, either the REST or SOAP, with low or zero code. Next to CXF is Narayana, the transaction manager. And the main objective of this transaction manager is to protect business from data corruption. by providing the complete and accurate business transactions. And it's Java-based, definitely, and mainly used for Java applications. Narayana provides support for a broad range of standard-based transaction protocols, including JTA, JTS, web service transactions, and also REST transactions. Next to Narayana is the web container under Tau. It's a non-blocking web container with modular architecture that allows users to build their own web container with the minimum footprint by combining small single-purpose kind of handlers together to create the overall functionality of the web. Fuse provides full flexibility for packaging and deployment. So once you are done with coding, right, Fuse is supported by 3 different containers or runtimes. So you can package Fuse as a fat jar and deploy it on top of Spring Boot, or as a standard WAR file and deploy it on top of JBoss EEB, or as an OSGI bundle and deploy it on top of Karaf. Also, Red Hat MQ, the message broker, is part of Fuse, but we will discuss it in the next slide in a separate section because we have separate slides for AMQ. Adding to the above, the ability to run Fuse on VM as a standalone or containerized, running on top of Red Hat OpenShift container platform. Last but not least is Fuse Online, the integration platform as a service, or what is so-called iPaaS. This is the iPaaS version of Fuse. It provides a cloud-hosted integration toolchain and runtime available directly from a browser, so no IDE. Everything is browser-based, where citizen integrators can enjoy the creation of integration flows and deploy the integration with 0 installation and 0 maintenance. This is the right tool for citizen integrators, where there is no code, no IDE, no build script, no packaging scripts, automated deployment, and automated change management. We will focus more on Fuse Online, since it is directly related to our main topic today, which is the citizen developers or citizen integrators. Fuse Online is shipped with a set of connectors, including database connectors, messaging, file adapters, social connectors, IoT through MQTT protocol, cloud connectors, and more. Users can easily extend the connector library by creating their own custom adapters and register them in Fuse Online and use them later in their integration flows. Red Hat Code-Ready Workspaces IDE provides a skeleton, right, for the Fuse Online extension project, where you can just plug in your code to create the custom connector for Fuse Online. Fuse Online allows users to create web services using a contract-first approach, right, by just using embedded open API editor, Swagger editor, or even using another module called Apicario, right, another API contract editor shipped with Fuse to create the open API specifications. So once specifications are created, users then can create the integration flows using drag and drop experience. So each step in the flow is represented by one of the components dragged from the catalog, the component catalog. So data also can be processed using components like splitters or aggregators, in addition to advanced data transformation services supporting either direct mapping, one-to-one field mapping, or combination, aggregation, or even a complex logic-based mapping, write your own logic, your own functions. Once integration is done, users can build and deploy the integration flow directly on OpenShift. The build and deployment process is fully automated, so no code or no script required to build or deploy, including even all the objects required for this integration service or integration flow to run on top of OpenShift. For any future updates, changes, right, user can always rebuild and deploy the new version of the integration services, leveraging all the capabilities coming with OpenShift platform, including the rolling updates, right, where you can simply push the new release with 0 downtime. Fuse Online also comes with a management tool to monitor, trace, debug all the running integration services. All the above and more is given as a self-service capability, where platform users can quickly provision their own integration platforms and start building their integration services. Next product is MEQ. So MEQ is a fast, lightweight, flexible, and secure messaging platform based on open source technologies, including. So we'll go through each and every component quickly. So the first component is the message broker. This is a full-featured message-oriented middleware broker with support of different messaging styles, the publisher, subscriber, the point-to-point communication, the store and forget message style. Also, it is fully asynchronous with non-blocking internal architecture. So leveraging either Java NIO SDK or the Linux native AIO for non-blocking IO. With a high-performance journal files, file system-based message store, but still we can use the JDBC connectivity to store the messages in databases. This can be easily deployed for maximum high availability with support from cross-data center deployment, support for standard protocols like MQB, MQTT. This is why it is very suitable for IoT implementations, in addition to other protocols. Also, a wide range of client SDK, including Java, Node.js, .NET, and C++. MEQ deployment pattern is pairs of master and slave brokers. So in the case of master failure, the corresponding slave will take over and starts receiving and delivering messages. The MEQ clients are aware of the server topology and get updates about any change in the topology, like, for example, adding a new broker or a master crashing or a slave taking over. So the MEQ client does not need any network load balancers because those clients, they know which broker they are connected to, and also they simply fail over the connection client side in case the connected broker fails or crashes. Another great feature of MEQ is the MEQ streams or Kafka. So for those who don't know Kafka, Kafka is a reliable message broker distributed by nature, supporting data partitioning, which again provides high performance and high throughput. MEQ streams encapsulates all the Kafka components, including the broker, the connect and connectors, as well as the mirror maker that allows cross data center message or data replication. Also the client SDK for producers and consumers. All these components are deployed and managed by operator that automates the deployment, installation, and the day-to ops, including the updates, the fixes, the batches, right? Everything is automated for the Kafka streaming platform. Another product in Red Hat Agile Integration Stack is the API management 3-scale. So once we have our internal backend services ready, we then think of how to secure, version control, scale, document, apply policies, and get analytics, and finally get API consumers, what is so-called API developers, to use those backend services. So 3-scale is an API management platform provided by Red Hat as part of the Red Hat Agile Integration Technology Stack. 3-scale has three main components. The first component is the API manager or the policy manager. This is a central admin console where you can create and manage your APIs. APIs can be created using the console screens, or can be also created by a command line tool called 3-scale toolbox, or it can be automatically discovered when they run on top of OpenShift. So if you have any backend services running on top of OpenShift, those services can be automatically discovered by 3-scale and used later or can be exposed later through the API gateway. The second component is the API gateway. This is where you apply the API policies as defined in the API manager.
The gateway communicates with the API manager asynchronously in an unblocking way. So this does not affect your API traffic at all. The gateway also has its own built-in caching to survive even with the absence of the API manager, because it caches the latest version of the policy, and it also caches the analytics. Once the API manager is back, the gateway will send back the analytics and also get a fresh copy of the policy. The third component is the developer portal. This is the API marketplace. This is where all the APIs will be published, and the API developers can find all the published APIs along with the active documentation to describe how to use the APIs, and also with the ability to subscribe to one of the available plans or contracts to access the published APIs. It also allows those API developers to manage their sub-accounts and also access their API analytics. So applying security in 3-scale can be done using 3 different methods. One of them is the API key. So simply generating an API key, and every API caller must have a valid API key to access our APIs. The second method is to use a combination of application ID and API key. And this is very suitable for the mobile applications, where you fix app ID for every mobile app, and then you generate different API keys for different instances of this application. The app ID is fixed, cannot be changed, while the API key can be changed. The third method is the OpenID Connect. This is a standard protocol to authenticate the client application and also end users connected to the application, or our API in this case. And it is one of the most commonly used protocols for authentication. So what does this mean? It means every API developer has to have a valid username and password. They will use the username and password to generate a token, this token called JWT. And this username and password can, for example, be coming from the LDAP or Active Directory. And then for the subsequent calls for the APIs, they have to provide this token to be validated. As part of the 3-scale distribution is Red Hat Single Sign-On. Red Hat Single Sign-On provides the underlying infrastructure for OpenID Connect, in addition to features like user federation, identity brokering, support for OpenID, OAuth 2.0, SAML protocol, as well as Kerberos authentication. Once we are done with the API security, the next step is to create an API plan or a contract to define how API developers are going to consume our APIs. Where we define the rate limits. The rate limits is mainly used to limit the number of calls to our APIs. In addition to, again, a dollar value that can be associated with every API call that can be used for the API economy. After the deployment, we start getting the analytics. So the moment API developers start calling our APIs, we can see the analytics, how many API calls by API, by a specific API developer account or across accounts. So the API manager provides a set of reports that show the API usage at different levels. Finally, the last component is the developer portal. This is an embedded content management system allowing the API owners to create custom content, apply their look and feel, in addition to, again, the ability to automate the payment in case of, for example, monetization is enabled and there is invoices, for example, pending invoices. So API developers can directly pay from the developer portal through the integration with some of the common payment gateways. In this section, we are going to discuss some of the key technology trends and the impact of those technology trends on the integration domain. Microservices, containers, open standards, open specifications, and DevOps. So when we're talking about integration, we have seen how the contract first or API first approach is gaining more traction, and most of the new integration platforms are adopting this concept.
So it is no longer the case where we start coding and later expose what we coded as let's say REST or SOAP or whatever interfaces. Rather than that, we first define the contract, define the interface, and sometimes even we provide mock-up services for the other side to be able to integrate and call the contract and start the integration from their side while we are providing the actual implementation of those contracts. Also, modularity, the fact that now every integration flow can be packaged as a single deployment or a build artifact and a single deployment unit, very in line with the concept of microservices, where those are small scale deployment units, and they are by design and by definition independently deployable and independently upgradable. Moving towards containers, that gives us the portability, where you can build the container once and run it everywhere. And containers, again, are very lightweight. Also, they are cloud native, so the container can run seamlessly on premise, on let's say physical infrastructure, virtualized infrastructure, as well as cloud infrastructure. Talking about open standards and open specifications, we said that open APIs, Swagger documentation, as well as the pattern-based integration is a key success factor for any integration technology stack. Last but not least, the DevOps that again defines the way the different teams, including the development and operations, can work together, adopting the same set of technology, set of tools, set of processes, and also change in the mindset and the culture within the enterprise IT organization. The key technology strengths definitely adds great value, but they also come with some challenges because those small microservices that are containerized and produced through DevOps-enabled processes, adopting new or open specifications, and deployed across different infrastructures, including on-premise and cloud. They also need to be distributed. We need to be or carefully handle the security and take care of scalability, how to scale those microservices or containers to run in different environments. And also we have to provide a level of observation to observe those services. Also, in case those services they fail, there has to be a recovery mechanism, and also discover those services in terms of what do they run and where do they run. So this is where we are talking about something beyond the integration platform capability, something where all the integration products will be running, enjoying those features and capabilities. And Red Hat strategy here is again providing the full technology stack, including Fuse, AMQ, 3-scale, as well as Red Hat single sign-on, containerized, certified, and running on top of OpenShift to enjoy all the container platform capability. So end users, citizen developers, or even core developers will be enjoying capabilities like Service Catalog, where they can quickly navigate through the Service Catalog and select any service, including Fuse, AMQ, 3-scale, and with a click of a button can simply provision them. And as we said, self-service, so you don't need anymore to go back to your operations team or infrastructure team for sake of provisioning a message broker or integration platform. Built-in DevOps tooling, so you don't need to go outside the platform for sake of building your CI/CD pipelines or automating your build or deployment. Also, the need for scalability leads to some challenges in terms of network configuration and the load balancers, right, and the reverse proxy setups, right? So OpenShift comes with built-in load balancing. So the moment you scale your containers to run multiple instances, you don't need to do anything because the platform comes with a built-in load balancing. Also service discovery, so I don't need to really worry where my container or my microservices are running, because no matter where they run, there is service discovery built in within the platform, allowing me to quickly reach out to those services and start consuming them. Also, we can simply delegate the scalability challenge to the platform by setting up the auto-scaling features. So the moment we get some load, the platform will take care of scaling out those containers to take the punishment. Once we go back to the normal operations, right, again, the platform will scale it in again to the minimum configuration. Also, self-healing, any of those containers crashes or any of those microservices crashes, the platform will take care of bringing it up again without any human intervention. Also enjoying things like zero downtime deployment, so the rolling updates or even advanced deployment approaches or mechanisms like AB blue-green deployment. Also, the built-in capability within the platform that gives you out-of-the-box logging, metrics, role-based access control, team and quota management. In addition to the other frameworks and other platforms running on top of OpenShift, including the service mesh that comes with built-in traceability and observability, as well as the serverless implementation where you can enjoy, for example, creating some integration flows and run them as functions within the serverless platform. So we actually sometimes get this question, don't you feel this is too much for a citizen developer to take? The answer is no, because if we look at the set of capabilities provided by the platform and on top of it all the integration products running there, you will hardly find any of these features or capability require, let's say, kind of intervention from the citizen developers. Looking at, for example, how to provision any of these capabilities on top of the platform, including, let's say, I need to create my own Red Hat Fuse online instance to start building my integration flows. It is auto-provisioning, right? And also including the day to ops part of it. So if you need to apply patches, fixes, or upgrades, the operators comes with OpenShift will take care of this. The only, let's say, responsibility stays with the citizen developers is how to build those integration flows, yes, with no or low code, right? And everything is web-based. When it comes to build, things are automated through OpenShift S2I engine or the built-in CI/CD pipelines. When it comes to deployment, again, automated deployments through OpenShift deployment objects and the built-in CI/CD pipelines. When it comes to configuration management, OpenShift has out-of-the-box configuration management objects, including config map to externalize the services or the application parameters, as well as secrets to store securely the sensitive data required by the services, and also the deployment object that allows you to bind those config maps and secrets to the running containers and deliver the value at runtime. In terms of scalability, OpenShift also comes with auto-scaling that allows you to quickly scale in and scale out your workloads based on the, let's say, some metrics, including CPU consumption or memory consumption. Resiliency, as we said, OpenShift provides a self-healing capability for all containers running on top of it. So you have one of the integration flows deployed and running on top of OpenShift. The moment it crashes, OpenShift will bring it up again. Also, the shared services provided by OpenShift, including the logging, metrics, observability, and traceability capability. So I think this is the time to look at the demo. We will share more demos. But our focus today will be just walking you through the citizen developer experience using Red Hat Fuse Online.
In today's demo, I'm going to walk you through one of the key features of Red Hat Fuse Online that allows you to quickly expose your database over REST interfaces, what is so-called data services. So our scenario, we have a database. This database has two tables, so we are going to focus on the to-do table. So select star from to-do. So this table has three different columns: ID, task, and completed, and we have a set of records already there. So we need to extract the data from to-do table and expose the data over REST interface. So the starting point in Fuse Online is to create integration. So creating integration by, again, selecting the API provider, which is the REST interface. So you can either upload the REST interface definition if you have it in your local drive, or you get it direct from online URL, or you create it from scratch. So we are going to create one from scratch. So there is a quick way of doing it by actually adding the data type. Data type is the underlying data type that this REST interface is going to expose, which is the response. So for, again, to define the data type, we can simply provide a JSON sample of this data type. So our data type will have one attribute, which is a task ID, and it's numeric. Another one, which is task name, which is string, and last is task completed flag, which is numeric. There is one option here, which is the REST resource. If you click on it, so this will allow Fuse Online to create all the standard REST operations to manipulate this data type. So it means we will find all the REST operations required to retrieve the tasks, add new tasks, delete tasks, or update tasks. So by clicking save, as you can see here that a /tasks path already defined, and we have the HTTP GET that retrieves the list of tasks. While when we have the task with task ID parameter, through the GET, again, we're getting the specific task. So we just need to save this REST interface. We give again task REST API, and then save and continue. So the next step is to create the integration flows. So simply we need to tell Fuse when we hit the REST URL/tasks, what will be the integration flow. So we will first create the tasks flow by clicking on create flow. Here Fuse allows you to add different steps. So one of the steps we are going to add here is the database step. So we need to simply go to our database to invoke either a SQL statement or a store procedure. In our case, we will be invoking a simple SQL statement to retrieve data from, so select star from to-do table. That's fine. Clicking next. So now what is left is to map from the SQL results to our REST data type, which is the task object we created in the previous step. So for mapping, we just click on, again, add data mapper task. Fuse Online will open the visual mapping tool that allows you to map from the SQL results to the REST response. So by just drag and drop ID to task ID, task to task name, completed to task completed. As you can see here in the properties panel, right, you get the SQL results completed column mapped to the response task completed. So once we are done, we just click done, and we save this integration flow. The second flow we are going to create as well is /tasks task ID that retrieves a specific task based on the task ID. So just click on the task ID. Again, we will be adding the database step. and invoking SQL statement. And this time we are going to select star from to do where ID equals a parameter which is ID, and clicking next. So there is an important step here, which is how to map from the REST parameter task ID to the SQL parameter ID. So we'll click again and add data mapper. So Fuse automatically will get us the REST parameters, which is the task ID, and the SQL parameters, which is the ID as defined in the SQL statement. So just drag task ID to ID. So this means get the parameter passed through the REST interface and assign it to the SQL parameter ID. So done. So now we are left with one more step, which is again mapping from the SQL results to the REST response. So we're adding again one data mapper from the SQL results. So completed again maps to task completed. ID maps to task ID. Task maps to task name. So once we are done, save this flow as well. So right now we have two flows, which is /tasks using HTTP GET or /tasks/task ID using HTTP GET, the other one. So again, the second step is to publish this integration scenario. So by clicking publish, so Fuse Online now will be first compiling this integration project, which is the assembling all the again the dependencies and build the artifacts. And the second step is to build the container image where this integration scenario will be deployed. So what is happening now is that while Fuse is building the container image, it will be pushed immediately to OpenShift. So as by end of this build process, we will find again one pod here created where our integration scenario will be deployed and available for end users to access it. So as part of the deployment process also, Fuse will create all the necessary objects in OpenShift required to expose this pod, including the service object as well as the route object. So let's go back to Fuse Online to watch the building process. So while Fuse is building the integration scenario, you can also see that it gives us quick statistics about how many integrations we currently have, how many connectors are defined, and also in total how many messages have been received, either successfully processed or failed. And also for each and every integration scenario, there will be a set of operations where you can view, edit, start, delete, export, or even configure the CI/CD for this integration scenario. We can see in our task REST API integration scenario now, the deployment is happening. If we go back to OpenShift, good, we will figure out that the container image is built, right? And there is a pod already running, and the service object is created, and we have the route created. By clicking on this route, we just accept the self-signed certificate, and we test the first REST operation, which is /tasks. So as we can see, we're getting all the tasks in the to-do table. And the second scenario, we're picking up one of those IDs, let's say 46. So again, Fuse will be selecting the task record of the ID 46. So this was the demo, and we merely here showing how to quickly extract data from your backend databases and export them over REST interface through what is called the Citizen Integrator experience. Now the time to take this REST interface and expose it over Red Hat API Management 3 scale. So at the starting point, right, this is the management console for 3 scale. So we create a new API. You just give it a name, tasks API. So once the API is created, you can look at the configuration, edit the configuration. Here, 3scale will allow you to either use the standard API cast, right? Or else you can define or select other gateways if they are available. So in our case, it's only one API gateway available with this install base, and also we have the different authentication methods, either API key, app ID, API key, or open ID. So for this API, we're going to use a simple API key. So update the surface, that's fine. The second step here is to integrate the API with the existing API gateways. Let's quickly look at the API. We remember that we have created at least two methods. One of them is to get list of tasks. Another one is to get a specific task based on task ID. So we're going to create those two methods here. The first method is to get list of tasks. The second one is to get task based on task ID. Okay, and now we need to map those. We need to map those methods in the integration. So this is the API base URL. I'm going to use it here. And we'll be adding one method which is tasks maps to get tasks. Another one which is tasks task ID, and this maps to get task. So let's update. Okay, I'm going to just get the production. Okay. And this is the staging. And update the same here. So that's fine. So now we created the API and we integrated the API with our backend endpoint, and also we mapped two methods, task/task ID, to the API methods, right? We can leave the default one, which is the hits, otherwise we can delete it, it's not required. Okay. Also, you know, the authentication method, we have selected the API key. So by default, right, the API key name will be user underscore key, and it will be passed as a query parameter. We can still choose to pass it as HTTP header or using even the HTTP basic authentication. For our case, we'll just keep it as a query parameter. Also, we can introduce new policies, right, to the gateway. So 3scale comes with standard policies, right? And also you can create your own custom policy. So it can be, for example, something like IP whitelisting. So if we need to, for example, IP check, if we enable this policy, we will be able to, again, get list of IPs from whatever options, and then we add the list of IPs, right? So for our demo, we are going to again use the standard C-scale API cast policy. So the next step now is to create what is called application plan. So application plan is the contract where we define, let's call it tasks basic plan, tasks basic plan. We define two things. The rate limiting, right? So it means how many hits either lifetime or yearly or monthly or weekly, daily, hourly, or per minute. And also we define the associated dollar value if we need to enable monetization. So there are different options. We'll quickly jump to the plan definition. So here, for example, for the get tasks, we can define limit, right? So this limit can be, again, per minute, let's say 10 hits per minute. So it means we cannot access this method more than 10 hits per minute. You can define different limits. So you can say, for example, it is 100 hits per day or 1000 hits per day, but still cannot exceed 10 hits per minute. Also, you can define the pricing, right? Again, you have tier price, so you can say from 1 hit till, let's say, 500 hits, it's 0.1 dollar, and then you can also define from 501 to 1000 another, let's say, price or 5, something like this. Okay, so this what defines a application plan. So now we created a basic plan. So this basic plan introducing rate limit for the get tasks and introducing two pricing rules for get tasks. While get task, no limit and no pricing associated with it. So we just update the application plan. Very good. So now we have the API. We have the different methods. And we have the application plan. The next step is to create an application for a specific API developer to be able to use the API. So if we quickly go to audience and look at the different accounts, developer account, and look at the subscription, you'll find that again tasks API now it is there, so you can subscribe, default plan, read subscription. So before that, if we go back to our tasks API and look at the application plan, so we need to publish this application plan to be available. And also if we look at the API configuration, so now we have the integration, we have the API configuration, and as we can see, we have the staging environment where a version 2 of the API is already running on the staging and it's not yet promoted to production. Very good. So look at the settings. We'll just add the default plan. Very good. And now the time to go back to our audience, developer, and look at the applications. So we'll create a new application now. So this application is mapped to the tasks basic plan, and we call it tasks basic plan. Read this application. Sorry, description, tasks basic app, read the application. And as we can see, 3Scale already created an API key for this API developer to be able to access the API. So just copy this API key and go back to our tasks API, and now we can say configuration, edit the API, task configuration, and once an application is created, 3Scale will automatically get the API key, right, to be used for testing. So if we provide one of the valid requests here and update the IP, we'll find that this green color means the connection between the client gateway API is working correctly and the response is coming. If we take this URL copy, right, and open a new tab and just paste this URL here. So as we can see, now we're getting the list of tasks from our backend API, or REST API through 3Scale. So the last step here, after we successfully define the API and map the list of methods, is to again promote the changes from staging to production. So if we just promote, so as you can see now the production OpenShift, sorry, to 3Scale, and looking at the overview and the analytics, we figure out that right now we have 11 hits, right? If we click on the analytics to get more details. So now we know exactly that, again, we get tasks, right? Total number of hits is 11, get tasks 5, right? And the get task is 1. And also here getting more details about the analytics. Also you can get the daily average, the hourly average, also integration error, if there is any integration errors. In this case, let's give it a try. Let's pass, for example, invalid key by adding 1 in front of it. So authentication failed. So definitely this will be reflected. Yes, so invalid key. One last step is to, again, add the active documentation for this API. So in the next demo, we will show how can we discover those API through the developer portal and access the active documentation. So again, create specification. It is tasks API, tasks API active docs, and publish it, and you can quickly go to Fuse Online and get the Swagger definition and add it. So create the surface. And now we have the active docs for this API already created, which is a list of tasks. Okay. Create a new task using post, delete existing task, get task by ID, or update task. So this is the scope of this demo. So to quickly recap what we did, we created an API inside 3Scale, mapping one of the backend APIs created by Fuse Online. So this API is exporting one of our tables in database and provide all the CRUD operations, including the create, retrieve, update, and delete. After creating this API inside 3Scale, we created the different methods and metrics, which in our case, getting list of tasks or getting a task by ID. And then we configure the API by integrating the or mapping the different methods to the endpoint URLs. And also we enabled the authentication method, which is the API key. After that, we created an application plan. So this application plan, we created different rate limits
and different pricing rules. After we created the application plan, we subscribed to this service, right, for one of our API developer accounts, okay, which is Task API. And after that, we also created an application that allows this API developer to access the application based on a specific plan. And then we were able to test the API using a valid key to get the response from the backend API. And we were able also to get the analytics in terms of the API usage, right? Either daily, hourly, top applications, response codes, alerts, and integration